I mean, does anybody like this at all? I mean, is it somewhat?
Once you solve it, you feel pretty good about yourself.
Yeah, like once you start getting them, you like it's a good feeling when you get it, right? Yeah. But it sucks when you can't, right? That's kind of the story of math, isn't it? Okay. Shall we do one more? Oh, you've got to see this one because, you know, just like with the substitution, there were some kind of crazy situations that would occur sometimes. Pardon me? This is number 8. Now, I almost did it. That's just like my instinct to want to erase anything on the board. That's a beta. Now, beta here is a constant that we don't know, right? It's a letter. Beta is a letter that represents some number that we have no idea what it is here. So that's a beta. Isn't this very similar to the problem we just did? Yes. I mean, we had sine pi t, didn't we? Yeah. The difference is that in our problem, well, we had sine pi x, but in our problem we had, what, x minus 1 out here or something? And in the previous problem, it was a cosine with an x, and then we had an x out here. So this is a squared instead of an x, right? So if I'm going to go with this, with the approach of integration by parts, I need to pick something, a u, keeping in mind that when that u that I pick in the new integral becomes the derivative of that, right? And so I want it to get cleaner as it goes instead of getting more complicated. So what in here would get cleaner if we do
t squared? T squared.
T squared, the derivative of that would be 2t. That got a little nicer, right? Sine beta t, the derivative of that would be cosine beta t times beta.
You have to pick the whole thing, right? You can't just pick beta t.
That's right, you can't. You gotta, your u and your dv must account for the entire integrand.
Okay.
Yep. So if I choose this for u, the derivative of it's not that bad, but that forces this one to be dv, and it becomes v in the other one. So the antiderivative of that would be 1/3 t cubed, so that just got more complicated. So I, again, think the instinct here would be to try and use the u to be the t squared. I'm going to put it right here. Whose derivative is going to be more simple on the other side. So our dv is sine beta t dt. What's du? 2d dt. What's v? So we need to go backwards from this and go back up with it. So it's right here if you need it. Negative 1 over beta cosine beta t. Yeah, we're in here doing this shit, and they're over there watching a movie. How fair is that? You always pick the wrong class, right? Damn it. That's a Cal 3 class. They're just watching movies.
Taking tests.
All right, so you ready? Here comes the ultraviolet minus voodoo. You ready for this? I'm going to do it over here because I keep on running out of room. So this integral up here turns into exactly ultraviolet negative 1 over beta t squared cosine beta t. So I always like to pull the constants out front, right? This is 1 over beta. That's a t squared, so I want to put the t squared behind that. So that's this. And then check this out. Plus 1 over beta, plus 2 over beta integral, where am I? T cosine beta t dt. What the hell just happened there? I thought it was ultraviolet minus voodoo.
Well, we changed all the signs because it interacted. In the
Yeah, what's voodoo, right?
You have a minus and a minus. So
I have a minus, right? So what numbers am I going to have when I do voodoo, v times du? I'll have a negative 1 over beta times 2, right?
Yeah,
And that can factor out,
that's 2 over.
and that'll turn the negative into a plus, and I'll have the 2 over beta on the outside, and then I have the t and the cosine beta t dt still inside. I did all that just to save myself the step of doing that next. So that's my new integral, right? Anybody recognize this integral?
What we started with, but it's the opposite. It's like the reverse.
The previous one.
Yeah, it's that problem we did earlier. It's x cosine something.
Okay.
How did we solve that problem?
Integration.
Integration by parts. Guess what we get to do again? Integration by parts again on that one. So we've got to pick another u, dv, and do the whole thing over on just this integral. So what's this integral, just this integral, going to turn into? A brand new ultraviolet minus voodoo. Yes?
Can you explain why that happened? I thought we were done.
Well, because you can't, your answer to finding the antiderivative of a function cannot be something plus some new integral. You don't want your answer to have an integral in it. Right? Yeah, it's a different integral, but we still don't know the answer to it,
Now, if
right?
it's a definite integral, can't you use it?
But you'd still need to know what the antiderivative of this is to evaluate at the two endpoints, right?
True.
Yeah, so you still need it.
Focus on that. And
Yeah, that's, yeah.
Other side apart.
Here's the way that I am going to do it in the notes and stuff that you would see, like all my solutions. So I'm gonna follow that pattern here. I'm just going to keep this line right here, okay? And then what I'm going to do is underneath this integral, I'm going to do a new table right there, underneath that integral. And I'm going to choose a u and a dv, just like I did over here. But it's a different u and a different dv, because it's a different integral. But I'm still going to use u and dv. So what u should I pick here? T, good. dv is everything else. So cosine beta t dt. Jack! 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 U is t, du is dt, here's dv, that's this. V, bring that sucker up, it's what? 1 over beta sine, right, beta t. Yes?
So is it going to be the same outcome for B? Like,
Is it going to be the same outcome?
what I mean by getting from dv to d, is it always going to be 1 over...
Well, if this is a trig function like cosine or sine, then it'll follow those formulas. This doesn't, every problem I've given you so far, we have a trig function. They're not all going to be like this. Yeah. But for all trig functions, sine or cosine, it'll always be 1 over, whatever was in front of the x, or the t. All right, I'm ready for my next line. All right, here we go. So here's what I'm going to write. My next line is going to be this entire thing, and then after this integral sign, it's ultraviolet minus voodoo, isn't it? So watch the way I write this. Equals negative 1 over beta t squared cosine beta t plus 2 over beta. Now here's my integral sign, right? So I'm going to put a bracket. And now ultraviolet minus voodoo. What's ultraviolet? T times this, right? So I'm going to put that 1 over beta in front of the t. So 1 over beta t sine beta t. That's ultraviolet. Minus integral voodoo. 1 over beta sine beta t dt. Yeah. I'm sorry? Well, this one is straight up. I mean, we don't have to do integration by parts because 1 over beta is a constant. So we just need the antiderivative of sine of beta, which is negative 1 over beta cosine beta t.
What's the dt at the end come from?
Right here.
Oh, it's the
Voodoo, right? Voodoo. That's why it's so important to put dt here, not 1. Just 1 by itself. Because you got to always have that d whatever in an integral.
That's right.
All right, so I'm going to do this. Everyone okay with this antiderivative using that formula? Okay, so here's where I am now. Negative 1 over beta t squared cosine beta t plus, I don't know. Do you want me to do this in brackets or can I multiply this through now? No, I'll wait. I'll go one more line. 2 over beta bracket 1 over beta t sine beta t, and then what is this? What is that integral, right, of sine beta t? Negative 1 over beta cosine beta t, right? But I have, so negative 1 over beta times negative 1 over beta cosine beta t. All of this, close the bracket, plus a constant of integration. Yeah, this is multiplication here. Any questions on where any of those things came from? This right here is the antiderivative of that right there. If you do that into this formula right here, you get this. The 1 over beta and the minus came from right there.
And you pulled the 1 over beta out, right? It's kind of like you pulled it out.
Kind of, yeah. Yes?
Could there be another plus c because we took the the first time and the second?
That's a good question. We should have several plus c's. At the end of the day, though, if you have a c from the first one, a c from the second one, it's all going to add together to be some constant. So we can always just represent the plus c at the very end as one constant at the end. Because we don't know what it is. It could be any number, right?
So that's the answer.
Well, no, we got to clean it up. Negative 1 over beta t squared cosine beta t plus 2 over beta squared t sine beta t. Let's see, plus 2 over beta cubed cosine beta t plus a constant. So I did this 2 beta through to here, and then 2 beta through to here. These two together are 1 over beta squared, right?
Yeah.
And then I came through with the 2 over beta, and that gave me a 2 over beta cubed. And then I still had this right here. That's my final answer, unless any of those are like terms, but they're not. Well, no, they're not. That's it.
Then we can always double check it.
You could always double check it by differentiating it or going to Wolfram Alpha and typing the original problem in. But the danger on Wolfram Alpha is that Wolfram Alpha, I've told you this already, sometimes they use identities that you're not aware of. So like their computer will actually like somehow combine these cosine and sines together using some obscure thing that you didn't even know existed. So you look at their answer, you're like, what? I must be wrong, when you're actually right. So it's just, yeah, they just get like 1. The answer is 1, yes.
So let's say, for example, it was cubed or raised to the 4th power, 5th power, whatever. Would this be the point where you keep going?
If what was being what?
If the original answer, because it was t squared, so if it was t cubed, then you would end up with
Oh yeah.
another one. So you have
Just imagine, yeah, the original problem was t squared, so we had to do integration by parts twice.
Right.
If it was t cubed, it would be integration by parts 3 times. And heaven forbid it's t to the 10th power, you know? But you see the idea. Huh?
Are we gonna play with
No, what we will do later next class, we won't do it today, is that we're going to come up with some general formulas. Like what if you have x to the n sine x? What happens? And then what we do is we create a pattern, and then we can come up with a formula off the pattern. Those are called reduction formulas. Number 10. P to the 5th, natural log P dP. So natural log P for you? Why? The derivative is 1 over P. But if you do that, then your dV is the P to the 6th, P to the 5th, which when you integrate it on the other one, it's going to become now P to the 6th, or 1/6 P to the 6th. So you're not worried about that?
Those are the easy. You can do those mentally, but sometimes knowing like that goes to whatever over whatever is a little tricky.
Sometimes what you need to do is just try each one and look real quick to see which one's better. Like I'm going to do this would never be my final worked out thing. This would be something I'd be doing on a scratch piece on the side. Seriously, I probably have a separate piece of paper over here. I'd just try this out real quick. I would just choose a U here, a dV. Let's see, I was told natural log P, and that would force me to use what for the dV? P to the 5th dP. Now the other thing I could have done is I could have chosen for U P to the 5th, right? But then dV would have to be what? Natural log P dP?
You put a 4.
I don't know why I did that. Right, those are kind of like my two options here. You see any issues? Any problems?
To go up.
What the hell's what is the antiderivative of natural log of P? I know what the derivative of natural log of P is, but what's its antiderivative? It's actually on your formula sheet. But don't look there. Don't look there. No. It would be nice if it was. What is it? Someone look real quick. What's the antiderivative? Just so everyone can see. No.
Oh, it's like a square root or something.
Antiderivative of natural log. I just want to make sure it's on there. It should be on there.
And then what's the derivative of 1 over x? Oh,
X natural log, or is it U natural log U minus U?
Yeah, I can write that down. The last page.
Last page of the formula sheet. U natural log U of U, or U natural log U minus U? Let me see. It's not on here? It's not on here.
So it's not an option anyway. So let's
Yeah, so it's not an option. So we can't, there is an antiderivative. We'll come up with it ourselves today. Well, I don't know about today, but well, actually, you know how we find the antiderivative of this? Integration by parts. But that's a whole another story. We'll do that in a second. So this doesn't look very good. Now over here, this is still my scratch work. Du is 1 over P dP, right?
Yeah.
And the antiderivative of this was what? 1/6 P to the 6th. And I was a little bit worried that by doing this, this gets more complicated, right? But look at what voodoo is. What's going to happen? 1 over P times that, you're just going to kill off a P, aren't you? That's no big deal. And you're just going to have a P to a power. And that's easy to integrate. Do you see how this is going to work great for us? So let me just use that. So U is natural log P, derivative of that is 1 over P, dV was the P to the 5th dP, bring it up 1/6 P to the 6th. What's my ultraviolet?
Natural log of P,
1.6.
Yeah.
Natural log of P.
I'm just going to write it that way. It's all the same because it's multiplication.
So it
But
doesn't matter if the B goes through?
it doesn't matter. You can put natural log of P in front. But I put that because if you put P to the 6 back here, you might think you multiply those two.
And you drop the integral because now we're in the formula, right?
We're in the formula ultraviolet minus voodoo now. Now here comes my integral. Minus integral voodoo. 1/6 P to the 6th times 1 over P dP. So we have 1/6 P to the 6th natural log P minus 1/6 integral P to what power? 5th dP. And hopefully everyone knows the antiderivative of P to the 5th, right? You already did it one time, so it's the same thing, right? 1/6 P to the 6th. So I went ahead and did the 1/6 P to the 6th here, and then multiplied it times negative 1/6 and got negative 1/36. That's it, we're done.
Okay.
So it's nice.
Some are gonna be okay.
Since I've got 10 minutes left, I can do probably one more. Are there any questions on this? We still have a long way to go on integration by parts. Yes? Yes? Ask, go ahead.
When we did it last time, we had an addition sign. That's why we had to find it again, right?
No?
In front of it, in front of the integral?
Right here? No.
When it was addition, is that why we had to do it again?
No, it was because what was left, we couldn't integrate.
Okay.
So we had to use integration by parts again because what was in here, we couldn't do anything with. This one, what's left here, P to the 5th, the antiderivative of that is just 1/6 P to the 6th.
Right.
So that's why I don't have to repeat.
And that's because of that formula right here, right?
Yeah, the power rule. You only go again if this integral is something you can't figure out. So let's go ahead and come up with the formula for this, everyone, since it's not on your formula sheet. And I'll let you put it on your formula sheet, okay? I told you you weren't allowed to write on your formula sheet, but this one you can put on there, because I'm surprised it's not there. The antiderivative of natural log u. This example is really going to help us appreciate the power of the integration by parts. Because, I mean, how are you ever going to figure out the antiderivative of natural log of u? I mean, how do you figure it out? Like, the derivative of what gives you this? Who knows? Well, let's try with integration by parts. Let's try something, right? We've got to pick a u and a dv. Oops, can't pick a u and dv. Why? I already kind of have a u, right? I'm already using that variable here. So instead of doing u dv, why don't I use a different variable? How about w dv? Now that's going to change my whole, I'm using w, so it's not going to be ultraviolet. It's going to be like white violet minus, I don't know, voudoir, I don't even know. But you see, the formula is important, but sometimes we have to change the variable. Or you could just use x's here, and then use u's and v's, right?
Use X up there.
Well, doesn't your formula sheet use nothing but u's? That's the reason I did it. So our final answer will be in terms of u also. Okay. What are we going to choose for w?
LNU?
We don't have a whole lot to choose from, do we? LNU? Let's just try it. I mean, because can you take the derivative of that? Yes. How about dv? What's the only thing left for us to choose for dv? du, right?
What do you mean du something? Or these two?
Just du. That's our dv. All right, let's do this one up here. If dv is du, then what's v? U, right?
Yes.
So I'm going back up here. Now check this out. What's dw? 1 over u du, right? So what we've been doing ultraviolet minus voodoo, haven't we doing these two multiplied minus these two in an integral?
Now, but you can replace the dw with certain parts now.
Well, it's going to be this times this, right? It's going to be u times 1 over u. If you need to next to this, keep in mind that this is like the u, right? This is like the du. So we're going to be ultraviolet. So this integral becomes ultraviolet. What's ultraviolet? U ln u? Minus integral v du or v dw, right? So multiply those. It's u times 1 over u du. Y'all following me? And that becomes u natural log u minus integral of 1 du. What's the antiderivative of 1 with respect to u? U, right? What's derivative of u? 1. So what's the antiderivative of 1 with respect to u? U. So this integral is just u, isn't it? Plus c. That's it. The antiderivative of the natural log of u is u natural log u minus u. Yes?
Go from the first integral to the second on the bottom, just that part.
Where?
Like the u times 1 over u to the 1 du. Because that's u over 1.
This is u over u. Just
Oh,
cancel.
okay.
Yeah.
I'm trying to make it all complicated.
Okay. I did integration by parts twice. No. No, it's just a simple cancellation. And because we have just a few minutes left, I'll do a quick verification on this. I'm going to take derivative. This is a product rule, right? What's derivative of u? 1 times natural log u. Plus derivative of natural log u, 1 over u, times the first one, u. Minus, what's the derivative of u? 1. What's u over u? 1. What's 1 minus 1? 0. Natural log u. Okay? So what you should do for homework is, what, drink a lot? Is that what it's saying? That might help.
I think it is. Killing all the bad drinks.
This is page, you know what, I don't have the page number, sorry. This is section 6.1. So you'll have to figure out the page for the assignment. Well, you know what, I think I have it right here. Hold on. Never mind, I have it right here.
That's homework.
This is page 316 in the book. And you should do 1, 2. I did 6, 8, and 10, right? 6, 8, and 10. So why don't you do 1, 2.
1 and 2.
And then 3 through 9 odd. Okay, so do the first two. The first two problems, they tell you what u and dv are. So they say, try this for u and this for dv, and then do your integration by parts. Number 3, 5, and 7, they don't tell you. And 9, you just have to try some stuff. All right, everyone. More integration by parts next week. Get caught up on homework if you're not caught up.
It feels easier than killing one.
Does it?
I don't know what, maybe it's a teacher or something.
So, you know what? Honestly, let me turn this off.
Before we get the video edited.
Before I say this, before I'm on record.